Good afternoon, everyone, and welcome to your geometry lesson on finding the area of regular polygons. Now, ideally, I would have you working on Geometer's Sketchpad, doing this on your own, but this is not an ideal situation. So what I'm going to do is show you the sketch as I explain what the directions ask you to do. And in order to really grasp what we're talking about, I really would like you to treat this as you were doing this sketch yourself. Please pay attention to all the directions that are on the handout and concentrate on the connections that you're trying to get, because it really is a derivation of the formula, and in order to truly understand the formula, if you understand the connections here, it'll make more sense to you and you won't forget it. First, we need to take a look at the vocabulary used for regular polygons. Some of this is new and some of it is old, so let's get started. First is the radius, and the radius of a polygon extends from the center of the polygon to a vertex. Usually this is represented by a segment. It kind of looks like the spokes on a wheel. The central angle is the angle formed by two radii of a polygon, and that means we're looking at two radii that are consecutive. So for instance, this would be a central angle of the polygon. This would not be a central angle of the polygon. A side is the segment between two consecutive vertices. This represents a side of the polygon. And the apothem, you'll also hear it called the apothem, but it's technically pronounced apothem, is the perpendicular distance from the center to a side. And again, that's the distance that we're talking about, but it is usually represented by a segment. So EF is the apothem of this pentagon. That vocabulary is very important going forward. At this point, what I would normally do is ask you to work on Sketchpad and take a look at the handout. So if you'll follow along with me, I'm going to bounce back and forth into the Sketchpad file and show you what this sketch would have looked like. First of all, regular polygons are both, well, that should be review vocabulary for you. They are both equilateral and equiangular. And in order to get a regular polygon, what we would do is we would construct a circle, and we would get the radius of the circle and rotate it around however many degrees we need to create our polygon. If you look at the directions, the first thing you would have is a circle. Then we're going to inscribe a regular pentagon into our circle. Well, keep in mind that a pentagon inscribed in a circle would have a central angle of what? That's what you're trying to figure out in step 3. So go ahead, read step 3 and think about what you would use as the angle of rotation if you were given a circle and you had one radius and then you want to rotate it in order to create the sides of the pentagon. So what you want to get is this and this and this, etc. What would that angle have to be in order for us to rotate this segment over to here? Well, we would divide 360 by 5, and that would be a central angle of 72 degrees. In order to do that, we would go to our Sketchpad file and make that transformation. We would just create a circle, we would create a radius of that circle, then we would rotate it around the circle 72 degrees. So I'm going to click on this as my center of rotation, and then I'm going to rotate my radius 72 degrees. And I'm just going to continue to do that over and over. 72 degrees, etc., etc. And there I would have, with the circle, these 2 points would in fact create the sides of the polygon as such, and I would go around and eventually I would get this pentagon. So then we go down to the investigate section. We want to know how many triangles we formed in the construction, so that should be pretty straightforward. There are 5 triangles formed. It turns out that all these triangles are congruent. Why are they congruent? What did we do and what do we have in order to prove the triangle's congruent? Since we rotated a particular segment, that was a side, and we got the sides by rotating around an angle of 72 degrees. So we have side angle side. What is the formula in terms of B and H for the area of one of these triangles? Now they're asking in terms of B and H. That's our general formula for triangles, which is 1/2 base times height. Now we're going to be asked to transform this formula into a different formula that makes use of our pentagon. If you think about one of the triangles in our pentagon, A is the apothem. We know that we have those two congruent sides that are radii, and we have the side of our triangle S. What does it mean for a segment to be perpendicular? That's just a little very basic review. That it forms a right angle. If it forms a right angle, this is also the same thing as my height of the triangle, or altitude. If I write the formula for one of the 5 triangles in terms of the apothem and the length of side S, the area of one of the triangles, which used to be 1/2 base times height, is now going to be 1/2. My base has become S and my height has become A. And then it asks you to construct the apothem, which I've already done for you. Use the formula from question 4, I think that actually means from question 3, to write the formula of the entire pentagon in terms of the apothem and side length S. Well, I have 5 triangles. For the area of the pentagon then is going to be 5 times this whole 1/2 S times A. What is the perimeter of this regular pentagon in terms of side S? If I wanted the perimeter of the pentagon, and we know that it has a side length of S, what is the perimeter of that pentagon? Hopefully that's not a challenge for you. That would be 5S. Then it asks you to look back at your formulas for questions 5 and 6. So this formula and this formula. And it's asking you to find any common terms and what the common terms are. Well, keep in mind this could also be written 5 times 1/2 times S times A. And so my common terms would be a 5 and an S. Now they want us to substitute in for the 5S a P. P is my perimeter. So I'm going to take out the 5 and the S and rewrite my formula for the pentagon as 1/2 AP, where P represents the perimeter, or P is actually 5S. And that is now the formula we will be using to calculate the area of any particular polygon, 1/2 AP. And you can see where the derivation came from. Remember that A is my height and P is all of those triangles together. Okay, so that is a great formula that we are going to be using. Now you need to keep in mind a couple of different things regarding this formula. The formula is 1/2 AP, that's primarily what we're going to use, but it essentially represents 1/2 A, which is my apothem or my altitude or my height, times the number of sides and the length of each side, which is basically the perimeter. Now the things you really have to be careful of. This opens up a door to all kinds of problems, and let me show you. For instance, we like the 6-sided, because if I have a 6-sided figure, think about what happens when I draw this triangle. 360 divided by n in this case, which is 6, gives me a 60-degree angle here. And lo and behold, when I drop my apothem there, it becomes a 30, 60, 90 right triangle. And so we can use our relationships there to get any length that is missing. But you have to remember how this is being used. Often students will mistake this 60 or the 30. You have to be very mindful of what you're doing here. Now when you're given a pentagon, it's not going to be quite as nice. For a pentagon, remember, my central angle is 72 degrees. I'm just going to go like this because you'll see why in a minute. When I drop my apothem, this is 36 degrees. Here's 90. And what happens is if you're given the radius, such as, let's say the radius is 10, you need the apothem to get the area. So I have to find A, and therefore I have to use trig. But trig is going to give me the A, cosine of 36. That's going to help me find A, and I have to also find the side of the triangle. When I find the side of the triangle, I can use sine. That's only giving me this part. That's not the whole side. So you're going to have to double it in order to get the full side. Just be careful which angles you're using, which segments you're finding. Again, that's also true with the 30, 60, 90, because I'm only going to get this relationship out of the triangle. I'm not going to get the entire side. So those are the two tricky parts, really, that you have to be careful of when you are either using trig or 30, 60, 90 right triangles. Now I think the best way to practice this is for you to do a couple of problems. This particular worksheet has 5 practice problems on the front and 10 on the back. I'm going to leave it up to you however much time you have to practice on this. The first couple are pretty straightforward, then I'll go through 3, 4, and 5. You can pause here, try them on your own, come back in periodically and check with me, and then tomorrow we'll go through some of the problems on the back and continue to practice this for the next couple days. The first one is straightforward. You just plug into 1/2 AP, and it's a pentagon, so it's 1/2 times 3 times 5 times 4.4, and you should get approximately 33 centimeters squared. Don't forget your units here. That's going to cost you half a point on every problem if you do. And the approximate perimeter, so again, that's plug and chug because we already have the area. So I know that area equals 1/2 AP, and I know the area is 20,000 square feet, and then I would plug in to find the perimeter. That's a 9 times a P. You should get approximately 4,444.4, and that would be feet. These stay problems without enough information because these are the ones where you really do have to solve for a missing piece. Now, if we have a pentagon here and the radius is 10, I know that length is 10, and I need to find the area of the pentagon. How can I possibly do that? Well, I do know a couple other things. I know my central angle is 72, and if I use that and I kind of blow up an image in the middle of this triangle, it has a radius of 10. This is 36 degrees, and I need to find both the apothem and the side length. So I'm going to call this X and I'll call this Y. Neither one, well, I could call the X an A, but don't call Y S, because if you do, you're going to be confused later on. Could make this an A. If you do that, we can use cosine of 36 equals A over 10, and you should get the apothem is approximately 8.09. And then you could do the same thing but with sine to find Y. So I'm going to say sine of 36 equals Y over 10, and I should get approximately a 5.88, and my side length would be approximately 11.8. Now I have a very important thing I need to talk to you about here, and that is rounding. There is a store function on your calculator. I will show you how to use it tomorrow if you don't know how. Otherwise, you need to keep all these calculations in your calculator, which is kind of hard because technically your apothem here is going to be cosine 36 times 10. Your side length is going to be 2 times sine 36 times 10, and you'd have to keep all that in your calculator and multiply that by 5 1/2. Your answer in that case should be 237.8 units squared, but if you're not doing these carefully, you're going to get rounding errors, and that's going to cost you. We'll talk about a little bit about how to use the store function on your calculator, which is very useful. A regular dodecagon has a side length of approximately 4.3 feet and a radius of approximately 8.3 feet. In this case, I can use Pythagorean theorem to get the apothem. If I zoom in on this, what it's looking like, if here's my dodecagon, my apothem's going like this. I have a radius of 8.3 and a side length of 4.3. Well, I basically want to use just half of that 4.3 to represent this length here to get me the apothem. I would get the apothem as approximately 8.01, and if I use that in my formula, I should get an area of approximately 206.8 feet squared. In the last problem, it's a square inscribed in a circle, so you can just use your special right triangles there, and you should get an apothem of 4 radical 2, and I'm multiplying the side length would be 8 radical 2, and so I should get 128 centimeters squared. So if you have any issues with those 5, just let me know. And again, if you have time to work on some in the back, it would only be to your advantage to do so. Otherwise, we'll continue working on this tomorrow and tomorrow night. Have a great night, everybody. I will see you tomorrow.